All right, so our lesson for today is called the probability of the complement. So in all of these problems, we want to find the probability of something happening at least once. But that can be tricky when we are talking about doing an experiment multiple times. So the way that we are going to calculate this is by calculating the probability that it never happens, and then finding the complement, or the opposite of that. So sometimes we are interested in finding the probability that an event will not happen. The complement of an event, denoted EC, is the set of outcomes in the sample space that are not in E, and is calculated. The probability of the complement is 1 minus the probability of E. This will hopefully make some sense once we do some examples. So a fair coin is flipped 4 times. What is the probability that it lands on heads at least once? So since I'm flipping it 4 times, that's a lot of possibilities for my sample space, right? I will have 2 to the power of 4 possibilities for my four flips. So instead of finding the probability that it lands on heads at least once, that is the opposite of never landing on heads. So this is the opposite of never landing on heads. So basically, I'm going to find the probability of never landing on heads, and then finding the complement of that probability. So never landing on heads means that I only land on tails. Means only tails. And there's only one way to land on only tails, right? If I have 4 flips, this will mean tails, 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 right? So how many different possibilities are there total? So there's one possibility for landing on only tails. How many possibilities are there for flipping a coin 4 times? The order does not matter here. So there are 2 possibilities for the first flip, 2 possibilities for the second flip, 2 possibilities for the third flip, and 2 possibilities for the fourth flip. So total, the number of elements in our sample space is 16. So the probability of never landing on heads is 1, since that's the number of possibilities I have for that, over 16. So never landing on heads is the opposite of what I want, right? I want the probability that it lands on heads at least once. So the probability that it lands, on heads once is the probability that it never lands on heads, the complement of this. Complement. So this is 1 minus 1/16, which is 15 over 16. So the probability that it lands on heads at least once is 15 out of 16. That's the opposite of never landing on heads. Let's do another example. A 6-sided die is rolled 4 times. What is the probability that a 2 or a 3 is rolled at least once? So again, this is the opposite, that a 2 or 3 is never rolled. So what's the probability of a 2 or 3 never being rolled? Well, I have a 6-sided die. It's being rolled 4 times. So if a 2 or 3 is never rolled, then I have how many possibilities for a 2 or 3 never being rolled? Possibilities. Well, let's see. If I never roll a 2 or a 3, then for the first roll I have 4 possibilities, right? 1, 4, 5, 6. For the second roll, I have 4 possibilities. For the third one, I have 4 possibilities. And for the fourth one, I have 4 possibilities. So total, this is 64 ways that I can roll a dice 4 times and never get a 2 or a 3. How many possibilities do I have total? Total possibilities. Well, I have 6 ways to roll the first one, 6 to roll the second one, 6 to roll the third one, and 6 to roll the fourth one. So this is 1,296. So the probability that I never roll a 2 or a 3 well, there are 64 ways to never roll a 2 or a 3 out of 1,296 total number of ways to roll a 6-sided dice 4 times. So this is equal to 0.0493. And remember, I'm trying to find the opposite of this. So the probability that I roll a 2 or 3 once is equal to 1 minus 0.0493, which is equal to 0.9506, or 95.06%. So if I roll a dice 4 times, the probability that I roll a 2 or a 3 at least once is 95%. So you're pretty likely to roll a 2 or a 3 at least once. Alright, one last example. A card is drawn from a standard deck of 52 cards and then placed back into the deck. Find the probability that a red card is drawn at least once by the third draw. So again, this is the opposite of not drawing a red. So how many different ways are there to not draw a red? Well, I'd have to draw only black cards. So in the first time, there would be 26 possibilities to draw a black card. I place it back into the deck. So there are 26 ways to draw the second black card, 26 ways to draw the third black card, and this is 17,576. So there are this many ways to draw 3 black cards in a row. There are how many ways to draw a card? Well, there are 52 ways to draw a card the first time, 52 for the second time, and 52 for the third time. And this is 140,608. So the probability that I only draw black for the first 3 draws is 17,576 over 140,608, which is approximately 0.125. And only drawing blacks is the opposite of drawing red at least once, so the probability that I draw red at least once is 1 minus 0.125, or 87.5%. So when we're trying to find things that happen at least once, that can be tricky when I'm dealing with multiple times. So it's often more helpful to say that I never draw that, or roll it or whatever, and then find the opposite or the complement of that probability. So that is it for today. Let me know if you have any questions on the Zoom meeting, and I will see you later.